Okay, so here's our first exposure to acid ionization constants. These are used for weak acids. Up to this point, we've only done strong acids, which mean ionize basically 100%. But what happens if it doesn't give all of its hydrogens away, such as in the case of a weak acid? What if it only gives part of them away, such as in vinegar? It holds on to a lot of its hydrogens. What we're going to do is, just like we did it with equilibrium, the concentration of the products over the concentration of the reactants. For vinegar, it's 10 to the negative 5. It's pretty small. That means we don't produce a lot of the products. In other words, we don't have a lot of hydrogen ions that are ionized, so it doesn't have a very large pH, not a real strong acid. Okay, this table right here, basically you can compare, use the Ka to compare only acids with the same conjugate base. So if you look at H2SO4, Ka is 10 to the 2. If you look at, once you give away the first hydrogen and the second hydrogen, the Ka is much smaller. So it's easier to give away that first hydrogen than it is that second one. Okay, here's the first type of problem. There's two types of problems. I could actually calculate the Ka if I give you the concentration of the ions, or I can give you the Ka as in the next problem, and you can find the concentration of the ions. So it says we start with 0.2 molar of this. Some of it's going to ionize, right? We'll find out how much in just a second. And the pH, once it does ionize, is 2.23. So if we use our magical pH square, we can plug this into pH equals the negative log of the acid. What we're going to have to do here is we're going to use the anti-log, or the opposite of log is exponent. So when you do this, make sure you put this right here into parentheses. So 10 to the x button is what you want to use. Make sure it's a negative on there. And what that means is our final concentration of hydrogen is 0.059. So what we're going to do is we're going to go ahead and plug it into our table here. Start change final table. Okay, so we start with 0.2 molar of our formic acid, none of our hydrogen ion, none of our conjugate base. All right, we just calculated the final concentration of the hydrogen, which is 0.059. Whenever we produce one hydrogen, we always produce one of the conjugate base. So, same thing. Now we know the change. Okay. All right, where did all that hydrogen and conjugate base come from? It came from this. So this must have gone down by that much. Now we have the final concentrations. We can plug it into our products over reactants, and we get a value of 1.79 times 10 to the negative 4. Okay, so here's the second type of problem. This is, if I give you the Ka, I want you to find the concentrations of each of the ions. So here's our problem. 0.1 molar of hypochlorous acid. Here's our equation here. So we start with this, don't start with any of this, and then finally it's going to ionize. So we know we have to shift to the right. That's our only option. We don't have any H plus or conjugate base. So that's why these two are going to go up by the same amount. Where did that come from? It came from here, so that must have gone down by the same amount. We have our final values. Okay, so now what we're going to do is, just like we did with equilibrium, we're going to plug it into our products over reactants. Okay, so X is going to go here, that X is going to go there, that value, that expression is going to go there. Okay, so here's the nice thing. If you were to plug it in, so don't write into the rest of this stuff down for just a second. I'm going to show you the math. Okay, if we set it up like this, we need to solve for x. So you're going to go through all this algebra right here, blah, 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 and come out with an answer of 5.3 times 10 to the negative 5. But remember, this is a weak acid. Since it's a weak acid, it doesn't ionize much. So this value is going to be, this x value is going to be extremely small. So small, as a matter of fact, if you were to plug it in like this, over just 0.1, and set it equal to 2.8 times 10 to the negative 8th. What you'd find is x, once you factor in sig figs, equals 5.3 times 10 to the negative 5th. It's the exact same value no matter which way you do it. So you can do it whatever way you want. I would suggest doing it ignoring the x. I would suggest doing it that way. It makes the algebra really simple. Okay, you can do that. AP Chem suggests you do that, and you can try it for yourself if you'd like, but it comes out to be the exact same answer because that value is so small, it's a weak acid. All right, that concludes our lesson. All right, we'll work on this tomorrow. Have a great night, guys.